quite easy creation of distributed applications. It's got object persistence, again, distributed applications, and task-oriented infrastructure. So you don't create threads, you run tasks, which perhaps, from a human point of view, is kind of more logical. What I call green threads, what is called green threads is, for example, you can have as many tasks as you want, but if you just want to balance them over your two processes, you can do that. It supports different programming models, semi-procedural and fully object-oriented applications. It's event-driven, mostly. If you know libevent or C-sharp's kind of delegates, then that's kind of the closest. And it's, for example, network input-output is much easier to do because you don't need to distinguish between asynchronous input-output or synchronous input-output. You just put the option there, and there it is. It's got stack borrowing, so if you want to make stack threads, then you can. And no main functions, because it was felt that if you have a task, then you can just have a program class and no public synchronized void main, like in some languages. It's already got multi-language support, and I mean locale settings and languages and character sets. It has a virtual input-output model, so some protocols that come with it, HTTP, FTP, the standard kind of thing. It's got a library for command line options, so that all the options are standardized, like perhaps a bit like getopt in terms of making everything standardized, but in reality quite a far away. Better, I would say. It uses the concept of bundles, like OpenStep or Mac OS X, IDSA. It's got an exception hierarchy. D is a language with exceptions and with comparable speed to C++, and a consistent command line interface for all libd programs inspired by VMS. libd is generally very pluggable. You can write plugins for nearly every subsystem. You can have your own user-defined message passing rules over Ethernet or over whatever kind of thing you want. Object serializers for remoting, or whatever acronym you want to use for that. Plugins for virtual input-output, and automatic plugin loading. And which brings me to the design of the Slate project. If it isn't clear to you by now, libd is nearly 100% done in terms of being alpha. It's not released publicly yet. It's still being tested. We feel that we don't need to, if we can test for some bugs, then perhaps we don't need to release quite so soon, and it will be released at least at most a month after this. And Slate is just an idea at the moment, which we are in the process of implementing. So I'll describe Slate. It's based on libd, and no C code, just D applications. Implementing it would require removing some of Slate's subsystems and adding them at high levels of abstraction. We think that we could go further with Slate than libd has gone. And thank very much Madeleine Freudenberg for implementing libd and making at least this possible. The core of Slate consists of libd, the virtual runtime system, the virtual private network layer, the hardware abstraction layer, transaction manager, and CMs. And here's a nice diagram of how we envision Slate to look like. So you will have your kernel interface, syscalls, which libd will mostly talk to, but the virtual runtime system can talk to as well. The virtual private network, we believe, is a core part of any computer, because most of them are networked and you need to have encryption between points. There's no point in having, hardware abstraction, transaction, yes. Okay, so the virtual runtime system is a straightforward virtual machine. It will include tools for compiling and analyzing programs, such as the bytecode verification, which I've already touched upon. And it will have a set of very minimal class library mappings, not like the system namespace in .NET, hopefully. It's not particularly a new idea, we admit. It's the Singularity and SharpOS projects, for example, have got the .NET virtual machine to run on as its own, but these have been their own kernels, and they haven't gotten that far, except, well, Microsoft has, but they have quite a lot of resources compared to open source projects. I want to just say that I've talked about message passing concurrency a lot, and while I am a great supporter of message passing concurrency, it's for some tasks it's not ideally suited, especially if you're running things on your local machine, and there isn't any reason that you shouldn't be able to do software transactional memory or just plain shared memory if your program has enough privileges, because obviously you can't do them if you have a distributed system running. The virtual private network, need for clustering and network security, standard protocols, nothing new. HAL, the solid project of KDE, a great step forward, I think, and when KDE will be released finally next year, I think we can celebrate a little bit. And there is the kind of the HAL was proposed to be in the core part because there is really no reason why devices should be handled differently according to their manufacturer. I mean, most of them have kind of standard protocols along them. Perhaps not things like graphics cards, but the kernel can handle those. I mean, the standard interface then would be things like OpenGL or DirectX. The transaction manager, just another component. You need some part to allow transactions to run in CMS, and perhaps all of you are wondering what actually CMS is. And don't be scared by this slide. It's just a bit of concept implementation, relation management system, blah blah blah. If you look at, I mean, it's pretty obvious that we as human beings map concepts onto implementations of them in the real world. I mean, share is something you can sit on and not fall through. That's kind of a concept. And being kind of a person with a mathematical incline, the concept of, perhaps the easiest example is the concept of tuners. I mean, if you have a pair of shoes, that's an implementation of the concept of tuners, but perhaps not all of you see that all the time. So what is CMS is, the kind of background to CMS is that you should have templates for data which you store on your local system or distributed, but a distributed system is just a collection of local systems. And you have some axioms because you're not able to define everything in terms of concepts. That's what's proven. And it's like having a semantic wiki. What it is in a concrete level is it is a basic relational database where you can or you cannot change the table structure. It's got extensions for extensions for your own data types, so like like PostgreSQL or Oracle. And the example is if you have like a PDF or a book or a Word document, then if you have like a picture of Prague and you've tagged it to say it's Prague, if you want to learn more about it and you have some literature on it on your hard disk or whatever, it'll, because it's already seen that and made the link, you can just query your CM's store and it'll tell you. There's nothing to be scared of. Another example is running web applications. I mean, in the financial sector, for example, you need to know quite a lot of news relating to the companies that you buy shares with, you sell shares. And while this kind of linking is nothing new in specific areas, usually such systems are built in an ad hoc manner, which is not helped at all by the operating system, and we feel that it would be useful to have them built in a non-ad hoc manner. So to overview kind of what I said, the virtual runtime system, you would have higher level languages than D running on it, so you could have like Ruby or Erlang or whatever you wanted, or new languages. And the VPN should be prime method of communication with other computers for security reasons. CMS being the storage mechanism, and we consider these all to be very low level, as maybe paradox as it sounds. Slate, yeah?
How does your project relate to Plan 9? Because
it doesn't. I mean, we haven't collaborated with Plan 9. Plan 9 uses. Plan 9 uses some of the kind of concepts that we are doing here, but we're building on libd and the D programming language, and we believe that's the way forward. Sorry if that doesn't answer your question, kind of.
Can I have? Okay. Eric Raymond said about Plan 9 that Plan 9 is better than Unix. It doesn't use POSIX. It has many similarities to your approach, but it didn't take off because Unix is just not bad enough at doing its stuff. So maybe you have many great ideas, but it won't be really useful.
It's always a gamble when you take on such a project to kind of try to realize those ideas. I mean, and make them popular. I would say that we have a good chance of succeeding because we're at least a bit later on in the.
Yeah.
Like, okay. Yeah. That we're using, I mean, things like CMs, etc. We think basically that we're making a bigger step than that Plan 9 has made, and I'm sure if you and that's the reason we'll succeed. Okay. Thank you. Okay, because Slate would be targeted mainly at servers in the first stages. We feel that clustering is obviously a very important application, and why not have it at the systems level? And libd already provides a message passing interface, object persistence, serializing over the network, nice network interface, and this would help us implement clustering, and obviously the message passing being the kind of method used for implementing it. Now we'll talk about security, a bit about class libraries and the file system built on CMS. Security functions, we build our basic premise for security